first, welcome to this session that we have for today, which is about understanding the SQL Trace, TKPROF, and the execution plan. My name is Carlos Sierra. These days, I work for Oracle. I work for Meta Cloud Services. But when I submitted this topic, I was working for Accenture Enkite Group. And this has nothing to do with cloud. I mean, this is about performance. I mean, performance, tracing, TKPROF, execution plan for beginners. So if you are developers, most probably that's something, I mean, you don't get to use every day, but every once in a while, and you need to do some diagnostics. Are we ready to start, or shall we ready? Okay. So I understand most of you guys are developers, right? So we have a lot of developers. Do we have any DBAs here in the room? You can leave. No, just kidding. just kidding. Myself, I'm a developer and I'm also a DBA, so I can relate to both sides of the house. Actually, I started working for Oracle 20 years ago, and then 4 years ago I left, and I recently rejoined Oracle. So during my 17 years on my first time with Oracle, I went through e-business, which I was working more on the apps, application side. And then at some point, I decided to join the dark force, which is the database. So I know a little bit of both sides of the house. So the agenda for today, first I'm going to say a few words about motivation. Why we care about tracing, TKPROF, execution plan as developers. Then I will get into more details about SQL Trace. And this is, if you have never seen a SQL Trace, who has never seen a SQL Trace before? You have, Mauro. So most of you guys, you have, who has seen a SQL Trace? Few hands, okay. So this is how it looks. Nothing new for you guys. We'll get to understand how to read that. Then we're gonna talk about TKPROF. That looks like this. And then we're gonna get into the execution plan. This is pretty much what we cover here. It looks something like this. So motivation, why we care? Why we care about tracing, TKPROF, execution plan? Some of you guys may relate to some of these bullets here. Either my report is taking too long, or I may have materialized views taking longer to refresh, or maybe within an application I have this particular page that suddenly is taking long. Or I just want to understand why, if I run this query on my development instance and I run the same in production, why in production takes longer. Or maybe everything is slow. So in this case, maybe it says here, the developer has to fix it, right? Well, when everything is slow, it's mostly the DBA responsibility to look at the issue. Well, quite common, we are here. Something in particular from the application is taking long. So in your mind, when you have a performance issue, who should be able to fix it? Who should troubleshoot the performance issue? Developers or DBAs? DBAs? No, developers, right? And what do you guys think? Is the responsibility of the developers or the DBAs? Both. Yes, sometimes, as a consultant and prior to being a consultant, I notice this often. Developers say, no, it's a DBA. I have an issue, the DBA should fix it, right? And the DBA says, no, I have an issue, the application developer should fix it. The reality is that both teams, they should work together and try to fix the issue. But the reality is that sometimes there is this miscommunication between the two entities, and one of the two has to actually do something regarding the issue. The problem is the DBA doesn't know enough about the application, and the application developers, we do not know enough about the database. So that's why we're here just trying to understand more, to learn more. So where do we start? I would say we start with a SQL Trace. Why? SQL Trace has been there for forever. I would say forever. When I joined Oracle 20 years ago the first time, SQL Trace was already there. And Oracle has been there for 40 years. So I'm pretty sure that early from the beginning, we had SQL Trace. It's a tool that is available, is free, is part of the product. It's not easy to read, but it has a lot of information about the performance of individual SQL statements. And as application developer, you create some code, run your code, you may have some performance issues. That is one place you want to see, SQL Trace. Within the trace, we find information about CPU and elapsed time. Let me step back a little bit. When we run something on the database, basically the time we spend, we can divide into two pieces. CPU and something that is not CPU. It could be something else. So the elapsed time, which is basically this time, is made of CPU, which is service time, plus some sort of wait event. And those wait events, they come in two flavors: idle, non-idle. Non-idle is something that we're waiting inside the database. For example, we read from disk, that is a non-idle wait event. It happens within the database. We're waiting on something that is legal, it's normal to wait, but it belongs to the database scope. And the one that is idle basically happens outside the database. What it is, from the database perspective, we don't know. We just know it happens outside the database. It could be latency on the network. It could be the user that went and did something. Anything that happens outside the database is considered idle wait event. So, and that is how the time is made. So we have elapsed time, which made of service time, which is CPU, and made of waits, and the waits they divide into two, non-idle and idle. Within the trace, we get to see service time, and we get to see elapsed time, and we get to see the wait events. We also get to find on the SQL trace something that's called execution plan. We see how many rows we process. We see some counts for some calls, database calls, how many times we parse, how many times we execute, how many times we fetch. We get to see physical and logical reads. There is a lot of information that we get in one trace. How do we trace? I mean, now I'm thinking as an application developer, I say, I have this SQL, how do I trace my SQL? Well, the process is you turn trace on, execute something, execute your application, turn trace off, then I find the trace and I review the trace. How do I review the trace? I can either go to the raw trace file, or I can use a summary like TKPROF, which basically inputs one raw trace file and it outputs a report that I can read. Then what do I do next? Well, I review the trace TKPROF, and then I can actually diagnose my issue. When it comes to turning trace on and off, in the old days, it was quite simple. We only had alter session set SQL trace true, or alter session set SQL trace false. That was it. That was the old days. And then, I mean, little by little, we have incorporated some APIs that actually are doing pretty much the same. These are just wrappers on top of the same command. So we have this wrapper that's called DBMS session set session trace enable, and we can pass some parameters. These are parameters for this API. For example, we have this parameter that says plan stats, which the default is null, which basically says, with null, basically says, give me execution metrics, but only for the first execution of my SQL. So that means if I take my SQL and execute it 3 times, with this API, by default, I only get metrics for the first execution. So when I produce my TKPROF, I can see the metrics for this one here. But I can change that and say, don't give me any metrics for plan statistics, or give me metrics for all the executions. Some small parameters that we have. And we can say at the end, DBMS session trace disable. That's one way to do it. There are some other ways to turn trace on and off. For example, I can use DBMS session set SQL trace true or false. This one is older. It's an older API. This has been there forever. That is the first one I learned. Alter session set SQL trace true or set SQL trace false. Or we can use something that's called event 146. That basically, when we do alter session set SQL trace true, we are setting event 146 level 1. That is what happens behind. We can use DBMS monitor, session trace enable or disable. we can use alter system. You never want to use alter system to do this or to do this. But you may want to use alter system, set events, and then you can pass here within single quotes this literal that says SQL Trace, SQL, and then put here your SQL ID. If you already know your SQL ID, let's say you're an application developer, you have a performance issue with this particular statement, you know the SQL ID, well, you can pass the SQL ID, pass in some extra parameters like, do I want to trace binds? Do I want to trace weights? I can say true or false. And then basically when I do that, I turn trace on those sessions where the SQL statement gets executed, when it happens. So the only caveat with this one is if you have multiple sessions executed the same SQL, well, every session is going to create a trace. So you may end up with many traces. So, but if you turn it on and then turn it off after a few moments, you may get to capture the SQL you want to trace without changing the application to do any tracing. Because one thing that happens often is in the application, we may not have a method to turn trace on and off. We don't have that. It's not implemented. Ideally, every application should have some method to say, I want to diagnose, I turn something on, and then trace gets enabled, turn it off, and basically I capture everything I did. That is in the perfect world. In reality, it doesn't happen often. Some applications like e-business, I know e-business for sure. I mean, there is a method to do that. Civil and PeopleSoft, I don't know if there is a method. And custom applications, it really depends on the application itself, if there is a mechanism. Well, if there is not, that is basically like a workaround to be able to trace a particular SQL by doing this command, and then we get traces for every session that executes the SQL. Is that clear? Don't wait until the end for questions. If you have any questions, just raise your hand. We take the question. There is also this thing that is called Aura Debug. Honestly, I never use Aura Debug. I have seen Aura Debug being used, but that's another story. But that's another method to turn trace on. And if you guys are familiar with Enterprise Manager, who uses Enterprise Manager here? Some of you guys. Okay, I know the DBAs says normal Enterprise Manager, but some of our developers are also using Enterprise Manager, right? That is a little bit unusual. Normally, Enterprise Manager it belongs to the realm of the DBAs. Usually, application developers, we don't get access to Enterprise Manager. But that's another method to turn trace on. When we do an alter session, like in this case, alter session says SQL Trace true or false, is easy. But sometimes we say alter session set events 146, trace names context forever, label n. The typical labels here is 1. When you are doing 1, this one is pretty much just turning trace true, is the same. But it has a little change. There was a little change here. When we were on 10G or before 10G, 1 means trace all the executions. And on 11G on, 1 means trace the first execution. There was a small change of behavior with the same value. Value 4 basically means give me binds, give me the values of the binds. Value 8 means give me the weight events. Value 12 basically means give me these two, which is the same as saying give me binds and give me weights. This one is pretty common, but at the same time, this one produces a file that is quite long. So 12, you need to be careful when you use 12 because you may end up with a file that is too long. I would say the most common one these days is like this one here. Show me weights, weight events. Because if I have a significant gap between service time and elapsed time, so that means I cannot explain all my time as CPU or most of my time. So that means I'm waiting on something. And sometimes that waiting to something is larger. We're using this one here. Is larger than the time that I'm consuming on CPU. So let's say, for example, my process takes 1 hour. But when I look at the CPU consume, it's 1 minute. So what happened the remaining 59 minutes? This is where I want to focus. In that case, I want to trace with level 8. With level 16, is for each execution after 11G. So basically, it's what we had here before. So you want the same that we had on 10G with 1. Then with 11G, we use level 16. And there are some other levels, like for example, level 64. This one is basically saying, give me the details for the first execution, then for every execution of the same SQL that took more than 1 minute. Does it make sense? So in that case, let's say you have the SQL executes often, and sometimes it takes longer than 1 minute. Yeah, you may be tempted to use this level. In real life, I usually use this one and this one, 1 and 8. And sometimes I use 12. But it's good to know that we have some others. So let's say we trace our application, we run it, we generate a trace file. How do we find the trace? That has changed over time. 11G and higher, we look for that name of the file on this $diag_info. It's a dynamic view. You select from that view and you get the name of the trace file. Before 11G, there is something called the user dump dest. You say show parameters user dump dest, and then you can see that. So if you are on 11G or 12C, you want to use this view. If you are on 10G, you want to use this parameter. Before I go here into going to the sample schema and looking at the execution plan, I just want to show you how a trace looks like. So let me just open a couple of files here so we can see that. Can we read that? So in this small script, what we are doing is something very, very simple, but that's a good example. I mean, how to produce a trace. We're saying in this case, execute the VMS session trace enable. So basically, we enable trace for this particular session. Have a one SQL. We execute the SQL, turn trace off. And this piece is just finding. It's basically saying from $diag_info, look for this column that says where the column name equals default trace file. This is a string. I'm looking for the value. That is going to be the full name of my trace. I don't know you guys are familiar with this syntax. Are you guys familiar with this syntax? Who is not familiar with this syntax here? It's not. Okay. Okay. On SQL+, this is executed from SQL+. When we are doing this, basically this one creates like a variable on the fly. And this variable is going to keep the value. Whenever we use full trace name, it's basically storing the value there into a variable. It's kind of, zoom. Let me see if I can zoom this one here. Yeah, it doesn't zoom. Text. The view. Let me see view. Text display. No, I don't think I can make it. But can you read it from? I tried the command plus and it's not working on this one. It's doing something else. Okay, you guys can read it, right? You can see it here, Mauro. Okay. Okay, so this syntax, the column, name of the variable, a new v, new value, and then the same column, basically allows me to select something into some variable, which I just defined, and then I can use that variable this way. So in this case, I'm saying, get the name of the trace, and then I execute a host command that's going to say, copy that name of the trace into my current directory. With that command, I'm just bringing the trace from wherever it is and putting the trace on my local directory. So now I can see it. Is that clear? It's just a trick, but since I use this trick, you may want to use similar tricks. And then once I do that, in this case, I'm saying, now, I could have done TKPROF and this thing here directly, as I'm doing here, TKPROF, blah, blah, and produce this file. So I don't even need this one here. I am doing this one to have both the trace and the TKPROF on my local directory. But if I only care for the TKPROF, I don't need this line. I can just go with this one here. And this one is just to show the TKPROF on my screen. So I don't have to exit SQL Plus and start looking at my file. It's simple, but that's basically the way you can see a TKPROF directly with a very easy command. And then how does it look like? The output file, it looks like this. So I can see my session trace enable. Then I see statements. For example, here, I was executing only one statement, like this one here. So I see my statement, I see some metrics. I see something here that is the execution plan. If you TKPROF, and when you TKPROF, we will see in a moment TKPROF, and you say explain equals something, have you used a syntax on TKPROF that says TKPROF blah blah explain equals something? No? Good, good. Because if you do that, what you get is the explain plan. And what we want is the execution plan. Now, when you do that and you get the explain plan, the label of the explain plan says execution plan, but that is not the execution plan. Okay? If we want to see the execution plan, it has to say this, row source operation. That is the execution plan. Just be careful, because sometimes you look at TKPROF, it says execution plan, and you're actually looking at the explain plan. Only when it's completed. The question is, do we get the execution plan only when the statement has completed? And the answer is yes. So we have to let it complete. So let me just get back. I will show you how we can get the max. Mauro, have a question or comment? No? Oh, thank you. Thank you. That's a trick. That's a good trick. Let's say your SQL is hanging. It's going to take forever. So you're running, you're tracing, you execute your SQL, you want to go home, you have to click Control-C, and basically dumps into the trace file. So you get it, whatever it has done so far. So that's a nice trick. Thank you, Mauro. Okay, so this is just, let's go to elaborate about that SQL. That SQL we're using as an example here. That SQL is based, it's a little bit out of focus. Can you try to put it in focus? It should be that one over there. I think, can you see it better? Hmm? Can you guys read it? Kind of, almost read it? Yes? Okay. So what do we have here? We have a SQL statement, and this is part of one of the Oracle sample schemas. When you install the database, you have the option to install sample schemas. And there is a sample schema that's called HR that contains these tables. And we use that kind of sample schemas for testing, for demoing. We use them a lot. So you're not familiar with the sample schema, that's something you may want to consider doing your testings and on sample schemas. We have some tables here, and we have the one-to-many relationship between them. You as developers, you should be able to understand this very easily. Right? Okay. Now, when we look at this SQL, this is a typical SQL, nothing fancy. We can see subqueries here, another subquery here. We're using some subqueries to filter. We're selecting from a couple of tables here. We have some filtered predicate. We have a join predicate. Nothing really fancy. If we try to explain what is this SQL trying to accomplish, can you tell me what it is that we're trying to do there on that SQL? We want to display employees. We want to display the email address of employees and some job ID. We're joining these two, right? For those employees that started after this date and for which the salary is greater than the average of the department, and the department is within the US. Pretty much that it is. Of course, there are much better ways to write the SQL, but I am a lousy developer, so I decided to write the SQL that way. So how do we get the trace for this one? I just showed you before. We say turn trace on, execute the SQL, trace off, get the name of the trace, and then I look at the trace. And it may look something like this. We have a header on top. We have some identification. I mean, with session ID, client ID, service name, module. All these pieces, they make sense if our application is instrumented that populates those values. It depends on the application. The application has to populate client ID, module name, action name. Service is, if we connect through a service, then we show the service here. Then we have some information coming here. We see when we turn trace on. If we continue with the trace file, at some point we see our SQL statement. Within the trace file, we can find the SQL ID, which is here. We can find, what is this HV? What does it mean? Hash value. Hash value of what? The plan or hash value of the SQL? Of the SQL. Of the SQL. In the old days, there was no SQL ID. You guys may not remember when Oracle didn't have SQL ID, unless you started like with Oracle. SQL ID was introduced on 10G. Okay, so before 10G, we didn't have SQL ID, so this is all we had, is the hash value. And then we have the address for the cursor. We have the time. This is the time stamp. What does it mean, this number? It doesn't matter. We only need this one as a reference. So if I know how much time happened between this one and this line, I just take this one minus this one. I just care for the gap in microseconds. So within the trace file, since we timestamp everything that we see, then between this SQL and this SQL, I can compute how much time was spent. Hopefully, in between, there is no user interaction. If there is no user interaction and I have a program that is quite long, I can see this SQL was executed here and this one started here. So there is some useful information on the trace file.
Why is that bottom parse?
The bottom parse.
Why is that one right there? Why does that one actually have an earlier time than the first one? Is it being printed out of order?
This one, oh, that's a good question. I don't know.
Before I've seen that. So I've always wondered. Usually it's only off by maybe like 1 or 2.
Yeah, 35 and 36. I don't have an answer. Mauro, you have an idea here?
I'm really sure they are right.
If, let me see, they look the same, 577, 577, 8536, 8535.
I've seen that before on my own trace file.
No, should not happen. I agree the first. Say again, Mauro.
Okay, so that was the bottom. Was it that?
No, not for this one. Yeah, but that was regarding CPU, regarding this guy over here. But regarding this one, it's the first time I see this. I didn't even notice this one here. That's a good point. Yeah, so we're talking here 1 microsecond. So I don't think it's too relevant.
It's not an issue, but it's the fact that like, why are they out of order?
Yeah, that's a good point. Yeah. Hopefully we don't see that often.
I see that all the time.
Are you guys?
I've seen it.
You have a really good eye to see that. Okay, so what is all this? I remember when I joined Oracle many years ago and I started trying to troubleshoot, because in those days, on the team it was part of the e-business, manufacturing. There was not a lot of knowledge, how to diagnose performance. So I said, I'm going to do it myself. So I opened a trace file and tried to make sense of the trace file, and I couldn't. So like, I don't know, I see a lot of acronyms, and I can guess what they are, but I shouldn't be guessing. I should either know or don't know, but no guessing. So I discovered this node, 39817.1. Okay, who here uses my Oracle support? Most of you guys, good. In those days, it was called MetaLink. And before that, we had something called WebID, which was around for quite some years. It was more like an internal tool, but we were WebID, well, hopefully it's no longer in use. That was killed like 15 years ago, right? Something like 10 years ago? It was killed, WebID, and it was an excellent tool. Yeah, it was a good tool, WebID. So if this node basically, and it's pretty much updated. this node, even though the number is so short and it has been for quite some time, the node is pretty much updated, so you can read it, and it basically tells you all those acronyms, what do they mean. So TKPROF. TKPROF inputs one trace file, generates a report. Can you guys tell me what it is? You guys should know. At least one of you guys should know. No one. Okay, then I won't tell you what it is. It's the Enigma machine. Yes. So to me, TK Trace in those days it was totally cryptic. I couldn't read it. So when I discovered TKPROF, it was like, wow, I can actually make sense of the trace file. So it was a long time ago. And TKPROF, you run it this way, pass the name of the trace file and pass the name of the output that you want. The syntax is very simple. Just say TKPROF, input, output. That's it. And all it does, it takes the trace file and basically summarizes. The trace file is created in such a way that it's parsable. So the event 146 is designed to create a file that you can parse. Actually, over time, there have been many tools on top of the trace file. One of the major, I would say, mainstream tools today is Method R. I don't know if you have heard of Method R. Anyways, I mean, have you heard of Trace Analyzer? Hopefully not. Good, good. I developed that when I was working for and then we have some extra parameters, like, for example, we can say sort. I use this parameter often. Say sort equal execute the labs, fetch the labs. All this syntax, what it means, it gives me my SQL statements and put on top of the TKPROF whatever is taking the longest. Which, I mean, when I'm doing performance, if I have a report that has 1,000 SQL statements, honestly, I don't want to read every single one. Just show me what is the top SQL. So with this parameter, you get the top SQL. So I don't have to read everything. I just go and read the top SQL. Questions so far? We're fine? Open source, yeah. I don't, Mauro, you have recommended before some open source parsers on the. What is the name? Ora M. Yeah, yeah. There are some good parsers which are open source and awesome. Are awesome. Yeah. So but don't use Trace Analyzer, okay? So we get TKPROF. In this case, we just add in these lines. Says TKPROF, the name of the trace, the name of the output. That's simple, and we get something like this. Okay. So anyway, so in this case, if we execute that SQL looks like this. We see the statement. Then we have these metrics here that says how much time we spend on parsing, how much time we spend execution, how much time we have on fetch. These times are seconds. And 20 years ago, seeing a statement that was taking less than 0.01 of a second, it was like a wishful thinking. Everything was taking longer, right? But in these days, quite often, I see statements that they take less than 1 millisecond. So they will show here as 0. So hopefully, we may get some better granularity here, because right now, we lose it. I mean, if we have a statement that executes only one time and it takes less than 1 millisecond, it will show here, we will show 0 time. So anyway, so that's our statement. We just made it a little bit bigger, so we get all those numbers. We see in this case elapsed time, 0.09 of a second, CPU time, 0.09 of a second. So that means there was no waits. We don't have a column for waits, but knowing this one, and we subtract this one here, we know what is the wait time. In this case, we have no wait time. This SQL was executed only one time, and it produced 2 rows. That is pretty much what I read from here. So far, so good. Now, when we look down, we look something like this. What is this? Is this an explain plan or is this an execution plan? There you go, execution plan. Why? Because it says row source operation. And it's supposed to show here the rows for the first operation, for the average operation, and for the max operation. I don't use this. I just care for one column. Go ahead. For Enterprise Manager, when you look at the plan, let me just give me 1 second. You see the execution plan. Because actually, on Enterprise Manager, when you go to the SQL, at the center of the page, it shows you the plan, but it's a list of values, so you can actually select different plans for the same SQL. So that means if the same SQL produces multiple plans, you can actually see the multiple plans. That has values tells you, yes, but on the prior page where you see the SQL activity, there is a column on the right that says what is the plan hash value that was actually used. So look at that number, say, and you need to memorize either the last 2 digits or the first 2 digits. At least that's what I do. And then when you go to that page and you see the list of values, be sure that you are selecting the same plan hash value. Yes and yes, it matches the row source operation. This is real. This is the actual plan that was executed. Enterprise Manager is also real. The only problem is if you have the same SQL that executes often, you may have multiple plans. So when you go to Enterprise Manager, unless you do what I said before, that's look at the activity, look at the plan hash value, then go to the second tab where you can actually see the execution plans and grab the same plan. Unless you do that, you may be looking at the plan that happened hours before. Okay? So we get that. Now, when we look at this execution plan, we're trying to make sense of this. It's becoming a little more complicated. We can read this. Yes, we can. There is a lot of information here, and we are mixing here CBO information. Like, for example, we have cost, size, cardinality. This is part of the CBO when the statement was parsed. And we have here execution metrics, which they happen when the statement is executed. So for any of these steps, we may have estimated number of rows, actual number of rows. We have both numbers, but they are kind of far away. So we need to understand this is when the statement was parsed. So if, for example, we see cardinality 107, the CBO was accurate. But if we see, I don't know, I don't see any errors here. Well, small errors. Cardinality of 17, 38. The CBO made a mistake, but it was a tiny mistake. In order to be a mistake that I should be worried, we're talking at the very least a couple of orders of magnitude. So that means if I see 17 and I see 1,000, then that could be a warning. If I see 17 and I see 5 million, that should be a red flag. Okay? Anyway, questions? No? So it looks like this is just making it bigger. These metrics, they roll up. The metrics of execution. For example, let me show you time. This time includes this time. Basically, whatever is indented is a child operation of the one that is to the right, sorry, to the left. So the metrics of the child operations, they roll up to the parent. So that means we can subtract and we can actually compute the time per operation. That gives you just an idea where the time was spent. Is that clear? Raw idea, but you may get an idea. I look at this execution plan, which is this long. With those numbers, I could find where am I spending the time. So this one is more scary. I mean, we have a lot of information, but we have to do a lot of manual processing. Then we get some wait events, like in this case. Some of these events are going to be idle, some are non-idle. Therefore, some belong to the database, some are outside the database. Unfortunately, here, we don't have a column that says what belongs to the database and what is not. Over time, you get to memorize them. So when you see the more than 1,000 events, you have a sense of what belongs to the database and what is outside. As a DBA, you're pretty comfortable. When you see SQLnet waiting for a client and stuff like that, you know where it belongs. But anyway, we have that. So with that piece, we can understand what is the gap between the elapsed time and CPU time. Now let's get into execution plan. Maria's not here, right? Maria is going to have another session on execution plan tomorrow, so don't miss that one. Okay, we're taking some. This is kind of practical. This is the way I do it, and she may be a little more formal on the analysis. So I suggest you attend Maria's as well. So the execution plan is basically a set of operations that we have in order to produce the result the SQL statement is asking for. Mostly we will see access operations and joins. To me, it's much better to understand the execution plan when I have the SQL statement side to side. I need to see both. That is me. I don't know if Mauro can do the same or not. Do you need to see the SQL statement and the execution plan at the same time? Kind of? Okay. There are some pieces that they don't come on the trace file. For example, the predicate information, they are not part of the trace file. But to me, if we have that information, that makes life easier to understand. Column projection is also useful, but mostly I would say predicate information. And figuring out the execution order could be a challenge. Actually, that was the very first requirement I had. Who has used before SQL T Explain? Some of you guys use SQL T Explain? One person, two. Okay. When I wrote SQL T Explain, I'm talking many years ago, the very first enhancement I was asked to incorporate was this one, the execution order. Because it was a mess. It's like we have the execution plan, but we don't know how to read it. So in order for me to explain to others how to read the execution plan, I had to incorporate a column on SQL T that says what is the execution order. I don't know if you have seen that column before, but it's there on the execution plan. Anyway, so regular operations that we often see table access operations, full or by row ID, index access, full, range, unique. I'm going to speed up here a little bit so I can spend more time on the execution. I only have like 20 minutes left, right? So I'm going to speed up a little bit here. So when we read an index, we usually navigate an index this way until we reach a leaf block, and then we read the row ID, and with the row ID, we read the table. So in other words, when we're reading one row from a table, we usually need to read one block, one block, one block, and from here, one block. Like 3 blocks from the index and 1 block from the table. It's typical. It's expensive for one row, but it's much better than trying to read the whole table to find one row. So indexes are very useful for a few rows, table access for many rows. Mauro has a session on full scan on this portion here, which happens next after this session. So for this part, I suggest, you attend Mauro's session. Join types, we have a bunch of joins, equi joins, outer joins, semi-joins, anti-joins, cross-joins, self-joins. All these joins are related to set theory, where we have inner joins, left outer join, right outer join. The message here is the database is dealing with sets. You, as an application, and as an application developer, as I did before, I tend to process one row at a time. Build a loop, get one row, do some processing, go to the next row, do some processing. For example, many years ago, I did payroll for big motor company. And my key mistake on that application was going row by row. I took one employee, right? And then for each employee, I went through all the different, payment attributes and all the contributions, and then compute the income, and then compute the tax, and then move to the next employee, and instead of doing this way. The application worked, and it was fine. The only problem I had is when every time I ran payroll, it took many, many hours. Then this guy, very young guy, came as when I was leaving. The project was functionally perfect, but performance, it was a big concern. So this guy came, and this guy rewrote the application in almost no time. And performance, it went from several hours to a few minutes, the same payroll, okay? So I didn't give that a lot of thought because I was just leaving out of Unisys mainframes, and I was getting to something totally different. But that was the first encounter I had with this concept of if you are thinking sets, you can get much better performance than if you are doing one row at a time. So my message here for you developers, start thinking sets instead of row by row. Anyway, so that was a little side. Subqueries. If you notice on all these SQL, we have some subqueries. And they have different names. Sometimes knowing the name is important Because you may find a node that says, oh, when you have a scalar subquery, blah, 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 you say, what do they mean with a scalar subquery? Basically means where and how we use it. It's just naming. When you know the names, then you can better understand what you see a node. Joining methods. In Oracle, we have pretty much 3 joining methods. Nested loop is dealing with small rows, a small set. Hash joins with large sets. Sort merge joins, we don't see this often anymore. I'm going to explain very rapidly how these 3 work. On the nested loop, on the execution plan, it looks like this. For every row that I return on the left, I find the matching rows on the left, on the right. Next row, matching rows. Next row, matching rows. And that is the nested loop. All the joins, they have 2 inputs and 1 output. They input 2 things here, and they output 1 thing here. Easy. So that's another way to see it. The driving table, in this case, is the driving table, produces rows, and then it loops over this table. And then if I have another nested loop, it's the same way. And the data flows. As soon as I get the first row here, and I find the first matching row here, and I find the first matching row here, it comes back here. So that means this nested loop operation is non-blocker operation. In other words, if I am reading millions and millions of rows, I start getting my first rows immediately. Does it make sense? There is no delay. I immediately get results. You may notice as developers when you're running a SQL, sometimes the SQL just pumps results immediately to the screen, and sometimes like thinking, and suddenly it spits the results. When you're finding yourself on the second situation, you have a blocker operation. Like in this case. On the hash join, the way it works, like in this case, we have a couple of hash joins. One hash join, another hash join. If we focus here, we read this object and put it into memory. And then once we finish reading the entire set, then we start reading the second set, matching, and as we match, we provide results. So this operation is blocking. And once this one completes, then we can start receiving results. So far, so good? Nothing wrong, it just works different. With a small rows, with a few rows, the other one is better. With many rows, this one is better. And the sort merge join, read one set, block, sorting, produce a result set, read the second set, sort, and then join. It's also a blocking operation. How do we get predicates and projection? We use this thing that is called DBMS Xplan. That's an API. I can say display, DBMS Xplan display, and get the result from the plan table. I have some formats. That's another parameter on this API. I can say give me advanced. That's a typical parameter. We can say display cursor, which gets me the execution plan for memory. This is the most common one. Has 3 parameters, which are the SQL ID, cursor number, and the format. The format, I like this one. Advanced, all stats, last. Just pass those 3 values. We say select star from table function, and then we say DBMS Xplan display cursor, and then we pass something here within parentheses. For example, here we're doing explain plan 4, have our statement, and then we say display plan table, null, and then this null is basically for a statement ID. We don't use that. And then we pass here a desired parameter that says what do you want? You want a basic, typical, all, advanced. If I don't say anything, I get advanced. This is just a small script to make life easier. Because now when I do explain plan 4, I can run this script and I can get something like this. In this case, I'm showing both TKPROF, where I can get the execution plan, and if I do the DBMS Xplan, then I get to see something like this here with some extra information. Now let's focus on this sample. I showed you this statement before, and we have 5 objects here, and the explain plan or the execution plan looks like this. In this case, this is the explain plan. We create the explain plan, not the execution plan. And we can make sense of it, but let's wait to see this one here. Yeah, and this one we're going to spend the remaining time. In this case, I'm showing here the SQL statement, which, I mean, we input that. I am showing you this piece, which may come either from TKPROF or it may come from DBMS X-Plan. It doesn't matter. I can get the execution plan from both. This piece comes from DBMS X-Plan. I cannot get this on the trace file. It's not on the TKPROF. So if I need this or I need this, they are coming from DBMS X-Plan. So in this case, I have to use, at the very least, DBMS X-Plan. So if I only have trace TKPROF, I won't be able to do this one here. So now, if you look at the statement, if I ask you, and I show you the execution plan, and I ask you, from all these different objects that you see here, which we have 1, 2, 3, 4, 5, if I ask you, which one is the first of those tables to be accessed? What would be your answer? Did you want here? Locations? So you are saying, in order to process this SQL, you process locations first. You would think so. Anyone else have a different idea? Yes, which one of the two? Because we have employees here and we have employees here. Okay, let's figure out together. No, that's the idea. That is the idea. The idea is figuring it out. Instead of just guessing, let's try to figure it out with facts. We see the execution plan. No, don't look at this one here, okay? That is Mauro. Okay, so if we look this way, I mean, as Mauro explained yesterday, well, if you know we're not on Mauro's session, basically we're finding what is the first operation here that has no dependencies, and this is one here. So we know it's employees, right? So right now we know we're going to study the here or here. It's one of the two. Now, we have a hint here that says, oh, this one is coming from a view that is a subquery. Well, this is not a subquery, therefore it has to be this one here, right? Let's be sure that it's this one here, that we start here. Well, this operation that we see, which is operation number 6, look at all this number 6. Well, number 6 is not here, but let's see if we can find number 6 here. Yes, number 6 is here. And look at the alias, E2. So now we know the first operation is this one here. This is the driving operation for this particular execution. It doesn't mean that it's the only possible way. There are many ways to solve this query. But in this particular case, the CBO decided to do this one here. Now, there is an issue. This operation has a dependency on something that happens externally. How is it possible that I can execute a subquery that is correlated before I execute the parent? It's like I have a child that is there and the parent is not born. Is that clear? How is it possible? Well, let's see what happened next. I mean, we're doing this operation first, and then we have a group by. A group by into what? Well, it's going to be a group by on this department ID. Let's see if we can see that. From this projection, we're getting the salary and we're getting department ID. We're getting those two columns. So we read the table. We group by department ID. Then we average the salary without knowing what is this yet. We just group by this one here and average the salary for every department ID. And we hold on those results. That is this part here. Is that clear? And then what do we read next? What is the second operation, the second table that we read? Well, if we look here at execution plan, the next one is what? Employees again. Guess what? Is the other one. Because we don't have an option, but if we don't know, then we take that 7, we look at that 7, and yeah, we're looking at E1. So we know that now the second table to be accessed is this one here. What do we get out of that table? Well, according to this one, 7, we're getting employee ID, email, salary, and department. That's what we're getting from the table. Everything else that is in the table, we just rule out. We don't care. We just get those. And then what do we do next? Well, if we continue the execution plan, then we do a hash join between those two objects. We have this hash join. For that hash join, number 3, we join through department ID. This one is not very clear, but we join through department ID, and then we filter that the salary on this E1 is greater than the average that we got. So now in your mind, you know how it works, right? We computed this portion first, just grouping and getting the salary, and then after we access E1, then we apply this filter. That filter, 5 minutes, thank you. Okay, so far we have done this hash join, which basically covers this operation, this operation, this operation, 7. From 3 to 7, we are done. So what is the next join? What is the next object that we join? Let me give you a hint. Job history. Good. What is job history? Here. So we start here, we came here, now we're in job history. For job history, what is that we're using? Well, we're using a nested loop. So that means for every row returned here, we're going to use an index on job history. This index, number 9, is based on which column? The leading column is employee ID. So we're taking the employee ID from E1 because of this predicate that we have, and then we read job history through that index. So basically, we do this and this, and we join here. So from 2 to 9, we have covered 3 tables. Employee 2, employee 1, and GH. We're done until there. So what is next? What is the next table that we join? So far we have, that was the first, that was the second. So what is next? And that was the third. So the next one is going to be this one here, departments. Departments is this one here. But look again, departments is associated to location, which is here, but we haven't accessed locations first. How do we get to join departments first, since we haven't joined locations? And locations is the one in which we have a filter. In order to do that, we can use this as an entry point. We can get department ID from E1 and push department ID as a predicate inside this view. And this is what we get here. We're pushing inside the second subquery, we're pushing a predicate. Which predicate is that? Look at the first operation within the view. Within the view, the first operation that gets executed is this one here. And let's look at the access for 13. Access for 13 is department ID, and we pass E1 department ID. This is the predicate that we're pushing inside the view. Is that clear? So once we push that predicate inside the view, then this department ID, that is the access point for departments. And then with departments, we grab location, and then we can join to location ID, and then we can filter this one here. So this one should be the last operation, which is on access here, on filter, which is that 14. We read through the index, so that means we use this one to access here, and then we filter on this one here. Does it make sense? So if I am correct to say, you should be able to totally understand an execution plan of this complexity. Is that a fair statement? Yeah, with some practice. With some practice. And start practicing with small statements, and then as you get used to it, then you will get to follow a bigger and bigger statement. But a statement of this size, you should be able to do it once you get back home, or maybe before drinks today. You practice. You practice. Okay, so SQL Developer has a different way to show the execution plan. On TKPROF, the information is there in big. Remember, we didn't have DBMS plan before, and the predicate information that we use is coming from DBMS plan. So that means in the old days, that's all we had, and we were able to do it. It was more time consuming, but we were able to do it. So summary here, with the trace, we can see the performance of a SQL statement. TKPROF doesn't require any license, which is good. We get the execution plan when the cursor closes. So that means if the SQL is hanging and we Control-C, it dumps the execution plan into the trace file, what Mauro said. DBMS plan is the one that provides predicates and projection. You need to understand what the SQL does. If you want to understand the explain plan, the execution plan, you have to invest time understanding what the SQL does. And then you can correlate the SQL to the execution plan. These two is like you put them side to side, and you should be able to go from the SQL to the execution plan and from the execution plan to the SQL. It's like one is the shadow of the other one. You need to be able to understand both. And after that, once you know how to do that, then the next step is on your execution plan, look where most of the time is being spent, and that is the piece of the execution plan that you want to diagnose further. Is that clear? Okay, so some references there, and questions we... Yeah. If you want those free tools, just stop by and ask Mauro. He will give you the names. And unfortunately, we may not have time for questions. We can take questions outside. And where to find me? Just go to my blog. You can see my email there. Just ping me. Any questions, follow up, whatever. Just ping me. You can find me very easily. I don't hide. So. So and keep learning. You never stop learning. So just keep doing. Thank you for coming.